limit here is basically what the function approaches as it reaches a certain x value here. As in this example, as x approaches c, you can see that the limit is L because the function goes to L from the left and the right. Even though there's no point, there's still a limit because it approaches it from both sides. It doesn't have to be continuous, as you can see. There's no point at x comma L, but the limit's still there. And for the graph on the right, there are 2 points where the function approaches, one from the left, one from the right. So the limit does not exist at x approaches 1 in this instance, because from the left, y equals 2, and from the left, y equals 1, and from the right, y equals 2. So to evaluate limit, you just plug in a value of x, as in this case, you just plug in x equals 4 as the limit of x approaches 4, and you get 7 after some math. But if you don't get a value for a limit like 0, 0, then you'll have to use some different methods like simplification or cancellation, however you want to call it. So you have this very weird looking set of numbers here. I don't know what you want to call it. And you can just expand it and then simplify it so you get just this nice, the limit of x approaching 0 of x minus 4, which would be negative 4. Or if there's a root in the numerator or denominator, you could rationalize. To do this, you just multiply by the conjugate, I believe, of the value of the root. As you can see here, root of x minus 4, parentheses minus 3 over x minus 13. You just get, after some math, you get 1 over root x minus 4, parentheses plus 3, which is 1/6. And some properties of limits. Here you can just see if you multiply by a constant, you get the constant times the limit of x approaching c. If you add or subtract two functions limits, you just get the sum or difference of two functions limits. Same goes with products or quotients, nothing special. And for the power, if you just want to take the limit of something and power it, you just have the limit. You can see here, limit as x approaches c of f of x is a. You just take the power of that. And the squeeze theorem is something interesting. You basically you compare other limits. Like here you have root x cubed plus 4 and root x to the 8th plus 4. And you have this unknown h of x here. You could just define the limit as x approaches 0. You can just plug 0 in, and since both the values are 4, the limit of h of x equals 4 because only 4 is less than or equal to 4, which is also less than or equal to 4. To solve using tables, you just look where the value approaches as x is a certain point. For example, here you have x approaching 2 of this function. You're given certain points. You can see as you increase from 1.9 to 1.999, it goes up. And then when it decreases from 2.1 to 2.001, it goes down. And you can see the number in between, which would be x equals 2. F of x is 1, so the limit of this function is 1. And Hopital's rule, or in French, règle de Hopital, if the limit is 0, 0, or infinity over infinity, which is indeterminate, you could use Hopital's rule, which is that if that limit as x approaches c of f of x and over g of x is equivalent to the limit as x approaches c of f prime of x over g prime of x, which means that it's the limit of as x approaches c of the derivative of f over the derivative of g. So you can see as this example, the limit of x approaches 2 of x squared plus x minus 6 over x squared minus 4, which goes to 0 of 0. So you can use Hopital's rule. The derivative of this function would be 2x plus 1 over 2x. If you plug in 2, that will be 5 over 4, and that is limits.